Hello friends, this video on equilibrium part 19 is brought to you by examfear.com. No more fear from exam. Before watching the video, please make sure that you have watched all the previous parts. As discussed, let's talk about the factors which may impact equilibrium. The first one is the change in concentration. With this, the QC change. The second one is the change in pressure. With this also QC change in volume. You add some inert gas. You change the temperature, you add some catalyst. In this case, there is no change, it doesn't impact. Other case, it impacts. In fact, this doesn't impact. So we'll talk about all this in detail. You change concentration, pressure, volume, you add some gas, change temperature. We'll talk about all these things in detail now. So let's talk about the effect of change of concentration. So if the equilibrium is disturbed by addition or removal of any reactant or product, then the Lee-Charter principle predicts that the concentration stress of the added reactant or product is relieved by the net reaction in the direction that consumes the added substance. For example, let's suppose I have A plus B gives C and D. So let's suppose I'm adding some reactants here. Then what will happen? The stress, the moment you add some reactants, so there's a stress here, right? And everybody wants to release the stress. And the stress will be released by some reaction that will be in a direction which will consume this. So what can consume? If I have two options, either the reaction in this direction or this direction. So if I have a reaction in this direction, will A be consumed? No. It will give more A actually. If I have reaction in this direction, will A be consumed? Yes. So that means if I add some A here, the reaction will be this direction, so that A is consumed. Okay. Similarly, if I add more B here, the stress will be created. And how it will be relieved? It will be relieved by allowing this reaction in a direction that will consume D, that is this direction. Similarly, for removal, if the stress is signified by removal, for example, you have A plus B is equal to C plus D, same reaction I will take. If I remove this, if I remove A from here, there is a stress created, right? Then how it will be removed? How it will be released? It will be released by a net direction or net reaction which will be in this direction, which will replenish the removed substance. This A is removed, then there will be a reaction in this direction which will bring back more A. Similarly, if I remove D from here, I remove some more of D from here, then reaction will happen in this direction so that more and more D will come. Here is a graph for that. Here I have the reaction of H2 plus I2 gives 2HI, the equilibrium reaction. So now in this case, if you see, the reaction was in equilibrium now. We had a fixed concentration of H2, I2 and HI. It's the equilibrium. Now we added some H2. The concentration of H2 went up. The moment you add some H2, the reaction is, the whole system is not in equilibrium. So if I'm adding now H2, what will happen? The system will move in such direction so that this is consumed. So it will move in this direction. That means now I2 will be consumed and HI will be formed. So if you see, the concentration of I2 went down and the concentration of HI went up. And since H2 is also consumed because it's going in the forward direction, so if you see, the concentration of H2 went down, the concentration of I2 went down, and the concentration of HI went up because the reaction moved in this direction. The reaction moved in the forward direction, so H2 and I2 is consumed to prepare HI. So the concentration of H2 and I2 went down and concentration of HI went up, and then again the equilibrium is established and then there is no more reaction. Again, if you change some concentration, the equilibrium will be disturbed and again reaction will happen. This is one of the property, effect of change of concentration. We'll take some real life example. So you must have observed that you have kept clothes for drying in the sun, but you must have seen that if there is a breeze, the air is blowing at very fast speed, the cloth gets dried easily. Why? Have you ever thought why? So what happens is, as I told, I have this container a box. In this I keep some water vapors, water itself. Water evaporates and then there is a vapor pressure here. The whole thing becomes an equilibrium, rate of evaporation and rate of condensation matches, and there is equilibrium here. So what happens here also, when you keep close for drying and there is no wind, there is a little bit of evaporation here, and then there is a local equilibrium, or again the semi-equilibrium form. I can't say very concrete equilibrium because equilibrium has to happen in the closed system, but again a very local level of equilibrium, very weak equilibrium is formed, but very weak equilibrium. And with that, since the vapor pressure in this area is more now, so some condensation also happens and it takes some time to dry if there is no breeze, right? Because a local equilibrium is formed here, and with the sun, even if the sun is there, it gets evaporated, but since the vapor pressure also gets created a little bit here, so I mean it takes time to dry. But if there is a breeze here, it will break this local semi-equilibrium, and then if there is no equilibrium here, right, that means here if what you are doing is H2O liquid, you are converting it to H2O vapors, gas. So if you are removing this now by passing wind, so what happens? This is nothing but you are removing the concentration of this, correct? Because this is my equilibrium reaction now. You are, by passing the wind, you are removing this gas, H2O gas from here. That means you are removing this. Since you are removing this, Lee Charter principle says that the reaction will move in the forward direction. That means more and more liquid will get evaporated faster, and then the clothes will get dried easily. Hope you understand this. See, H2O liquid to H2O gas is my reaction here. Is a equilibrium reaction happening when you dry the clothes. So in case there is no wind, everything is there and the system reaches this semi-equilibrium, I can say. So it takes time to dry up. But the moment you have this breeze here, it will break this, it will take out this H2O gas. Since this concentration is less, the reaction will move in this direction, and then your clothes will get dried easily. Same thing, we get more sweat in humid day. Similar thing here. So our body has to be in a certain temperature range. So what happens in hot days, or when you do a lot of exercise, your temperature goes up, right? The body temperature goes up. So what system does is, the body does is, you will sweat more. You sweat more, and this sweat is nothing but water, and this evaporates and it will cool down your body, right? So there is an equilibrium temperature that gets broken, or that is impacted when you do a lot of workout or when in hot weather. So in that case, your system will sweat, the body will sweat, and then this sweat will evaporate and cool down your system. So there also is trying to achieve the equilibrium. Also, if you see, this equilibrium of concentration plays a vital role in the blood. The blood transports oxygen via hemoglobin thing, and it works totally on equilibrium. So equilibrium plays a critical role in the transport of oxygen in our blood. Also, the removal of carbon dioxide from the tissue by the blood is also something which is done based on equilibrium. So we will not be touching more on this because we need more of bio concepts here. But just understand that our body itself runs on equilibrium, whether it is sweating or transport of oxygen, transport of carbon dioxide, everywhere equilibrium plays a vital role. Formation of ammonia also is one example where we have equilibrium playing a critical role. We'll explain this formation of ammonia using chemical process. Let's take one example or experiment for the effect of the concentration change. So here what we are doing is, we are taking this, let's suppose, iron nitrate, and this is potassium thiocyanate, thiocyanate. So if you take, let's suppose, 2 drop of potassium thiocyanate and 1 milliliter of iron nitrate, maybe you can take 1 milliliter 0.2 m, and this you can take is 2 drop of 0.002 m. This reacts to form this, and this is deep red. So you see deep red thing. Now let's try to change the concentration, because after some time it will be in equilibrium, and we'll see something like this. Let me write here. We have Fe plus 3 plus SCN minus gives Fe SCN 2 plus. Correct? We have this reaction. Now let's try to change something. Let's try to change the concentration of iron nitrate. Let's try to decrease the concentration of iron nitrate. How can we do that? To do this, let's add oxalic acid to this whole system. Let's add oxalic acid. So if we add oxalic acid, what will do is oxalic acid will react with iron and it will take iron from the system, right? So if oxalic acid is reacting with iron and taking iron, now what we are doing is we are taking out iron from the system. If you take out iron from the system will should behave according to Lee Charter principle in such a way that the reaction should happen in this direction, right? So that the effect of loss of iron nitrate can be fulfilled. So in that case, if the reaction happens in this direction, the deep red color should get diminished, and that's what will happen. If you add oxalic acid to it, oxalic acid will do what? It will react with iron nitrate. Iron nitrate will go off, or the concentration of iron nitrate will become less in the whole system, and thus the reaction will move in the backward direction, and the whole thing will become lesser red. The reddishness of the system will go down. Let's try to work with this guy, potassium thiocyanate. To reduce the concentration of potassium thiocyanate, what you can do is you can add HgCl2 to the system. You add HgCl2, what happens is the reaction is like this: SCN minus, it gives HgSCN 4. So we have this kind of reaction here. We have to give 4 here. Yeah. So this is the reaction we have. So the moment you have add HgCl2, it will react with potassium thiocyanate and it will decrease the concentration of SCN minus, that is potassium thiocyanate. And then again the reaction will move in this direction, and you see the red color will go down. Right? Okay. Let's try some other way now. Now let's try to increase the concentration of these, and let's see what happens. What you can do is you can, now let me write this once again. It's getting dirty there. SCN 2 plus. Now let's do one thing in this system, fresh system. Let's add some Fe3 plus. The moment you will add more Fe3 plus, what will happen? You will see that the concentration of this goes up according to Lee Charter principle. This reaction moves in this direction, and thus you will see the whole solution becomes more and more red. If you don't want to add iron nitrate, you can add this guy also, potassium thiocyanate. The moment you add, let's suppose 2 or 3 drops of potassium thiocyanate, you see that the concentration of this goes up, the reaction goes in the forward direction, and more of this compound is formed, and the system becomes more and more red. Thus, whatever we discussed logically that this should happen is actually true. We can perform these experiments in the lab using this equation, and we can just find that okay, the intensity of the reactant is increasing by seeing the color of the whole mixture. Let's take one example which talks about effect of concentration change. So there's a reaction, 2SO2 plus O2 gives SO3, and the equilibrium. The question says what will happen if we, let's take one example which says that what will happen to the equilibrium when more of SO2 is added to the system, and this is system equilibrium. So if you see, if you add more of SO2 here, what will happen? The reaction will move in such direction, the system will move in such direction that it will reduce the concentration of SO2. That means the reaction will move in forward direction. Very simple. Just by looking at the equation, you can tell that the reaction will move in forward direction. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.